grade 7 students? My name is Teacher Jerry, and welcome to our virtual math class. Today, you will learn new mathematical concepts, but don't you worry because I am here to help you understand the lesson. Before we formally begin our virtual class, I just want to give some rules for you to follow. First, always pay attention. Listen carefully to what I am saying. Second, enjoy working with the given activities. And lastly, always remember the concepts discussed after each session. Today, we will be talking about sets. I bet you might have heard about set, but in the context of mathematics, what do we mean by a set? How do we represent it? And how is it applied in our daily life situations? Now, let us proceed with our topic about introduction to sets. First, let's get to know the answer of this question. What is a set? Imagine we have these objects. We have a mango, a sampaguita, a dragon fruit, a dog, a carabao, a gumamela, and an avocado. And I ask you to classify them. How would you do it? What are the groupings that you can make? So, let's see if your answer is correct. We can actually group mango, dragon fruit, and avocado because they are all fruits. And we can have sampaguita and gumamela in the same group since they are all flowers. Lastly, we can have dog and carabao in the same group because they are all animals. In short, we group these objects because they share common characteristics, and these groups are called sets. Basically, a set is a collection of objects sharing common characteristics. You may not realize it, but we use sets in our daily life routines. We use sets when we select songs in our playlist. We also use sets to create a team of people. And we also use it to arrange books in the library. So, mathematically speaking, a set is a collection of well-defined and distinct objects. These objects that form a part of a set are called elements. In our previous example, in the set of fruits, the mango, dragon fruit, and avocado are the elements of the said set. How about if I ask you the elements of the set of planets in the solar system? The elements are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You're right! Can you also enumerate the elements of the sets of cities in the province of Ilocos Norte? We have the city of Batak and Lawag City. Correct! It is also important to note that not all groups are sets. For example, the group of interesting Filipino movies. Do you think that is a set? The answer is no, because the word interesting is not well defined. Meaning to say, my idea of an interesting Filipino movie may be completely different from yours. How about group of delicious Ilocano dishes? Do you think that is a set? Similarly, the group of delicious Ilocano dishes is not a set because what may be delicious to me is not delicious to you. How about first 5 counting numbers? is it a well-defined set? Correct. It is a well-defined set because the first 5 counting numbers are 1, 2, 3, 4, and 5. Remember, the important characteristic of sets is that the elements in it should be well-defined. Using describing words such as interesting, delicious, and more make it not well-defined. All the elements of a set must be well-defined. Now, we move on to our next lesson, which is all about naming and representing a set. How do we name a set? Generally speaking, a set can be named using a capital letter. Let's have, for example, the elements of the set of vowels A, E, I, O, U. The set of vowels can be named by any letter. For instance, we can name it as set A. Remember that it has to be capital letter. Capital letters can also be referred to as uppercase letters. However, if the elements of the set contains letters also, we preferably write them in small letters or what we call lowercase letters. Take note also that the elements of the set are separated by comma and enclosed by braces. Another important thing that we should know about sets is that the order in which the elements are written inside the braces is not important. So the set of vowels can also be written as I, O, U, E, A. Either way, the two sets are the same. Let's have another example. Suppose a set of even numbers from 2 to 10. What do you think are its elements? Correct. The elements are 2, 4, 6, 8, and 10. We can also have it in other order such as 8, 10, 2, 6, 4. However, though the order is not important, it's a good practice to write it in ascending order or descending order. We can name it by any letter. Let's say set B, which is equal to the set containing 2, 4, 6, 8, 10. Remember, in naming a set, we use any capital letter. Take note also that the elements of the set are separated by comma and enclosed by braces. If the elements of a set are composed of letters, use small letters in writing the elements. If the elements of a set are composed of numbers, arrange it in ascending order or descending order. How do we represent a set? We can have it using the listing method or the rule method. In the previous example, on the set of vowels, all we did was to list the elements of the vowels enclosed by braces and separated by a comma. This is the listing or roster method. Let's have another example. Consider a set containing colors in the rainbow. Suppose the name of the set is capital letter A. How do we represent this using listing method? So, we could write it as set A is equal to open brace, red, comma, orange, comma, yellow, comma, green, comma, blue, comma, indigo, comma, violet, close brace. Another way of representing a set is the rule method. Instead of listing the elements of a set, a rule indicating a property or characteristic common to all elements of the set and clearly indicating that only those which have the described property are elements of the set. In our example of the set of vowels, we can simply say set A is set of all x such that x is a vowel. The set of braces means what is written inside it is a set. The next important part is we have a variable here named x, but you can call it with whatever letter you want. This variable represents the elements of a given set. So, in our example, this can be read as all x. The vertical slash means such that. What comes next is the rule that describes the elements of the set. It says here, x is a vowel. Let's have another example. Consider a set whose elements are 2, 4, 6, 8, 10. The name of the set is set B. Represent this using rule method. Yes, you are right. As you can see, the elements are multiples of 2 starting from 2 until 10. So, we could write it as set B is set of all x such that x is a multiple of 2 from 2 to 10. Remember that there are two ways of representing sets, the listing method and the rule method. In listing method, the elements are listed, separated by comma, and enclosed by braces. In rule method, we use or follow the format, the set of all x such that x is descriptive characteristic of the elements. At this point, we are now ready to discuss about subsets. Suppose you want to buy an ice cream and you have 3 options to choose from: ube, cheese, and pinipig. Let's just denote them as U, C, and P. Let's say you can have only one ice cream at a time. It means you can have either ube, or cheese, or pinipig. That was simple. But what if you like having 2 ice creams at a time? What are the different possibilities? You can have ube and cheese together, or you may want ube and pinipig. Is there any other combination possible? Yes, you could also have cheese and pinipig together. In each of these scenarios, 3 sets were formed. Each of these sets is a different possibility. But what if you feel like having all of these 3 flavors of ice cream together? We could only have one possibility. In this case, a combination of the 3 flavors. And here's one scenario nobody wants to be in. Let us say you don't want any of these 3 flavors of ice cream. In that case, what we have is an empty set, or what we call null set. Don't forget the original set we were looking at. The original set was ube, cheese, and pinipig. This is the set of all kinds of ice cream we could choose from. The most important thing that we need to understand is that all the sets on the right of this main set. Yes, each set from the right is a part of this set. An empty set is also the subset of the entire set. And in mathematics, we say that each set is a subset of the main set. Suppose there is a given set, B, containing the elements 1, 2, 3, 4, 5. Tell whether the following sets is a subset of set B or not. First, set A, whose elements are 1, 2, 4. Because the elements of set A is also elements of set B. We say that A is a subset of B since every element of A is also in B. This is denoted by A is a subset of B. A Venn diagram for the relationship between these sets is shown below.
As you can see, the elements of set A are also elements of set B.
How about this example? Set D, whose elements are 2, 4, 6. Set D is not a subset of set B because one element of set D, which is element 6, is not an element of set B. That's right. The statement D is not a subset of B is denoted by D is not a subset of B. A Venn diagram for the relationship between these sets is shown below.
As you can see, one element of set D, which is 6, is not an element of set B.
Always remember that a subset is a set that is within a given set. We are already done with well-defined sets and subsets. So let us know more about universal sets and null set. What is a universal set? A universal set is the set of all elements under consideration, denoted by capital letter U. All other sets are subsets of the universal set. For example, if we only consider the following sets, set A with the elements A, B, C, set B with the elements D, E, F, and set C with the elements A, E, G, the universal set for these three sets would be U with the elements A, B, C, D, E, F, G. What is a null set? Is this familiar to you? We discussed this a while back. A null set is an empty set. In other words, it doesn't have any elements. But let us know more about null set. A null set or empty set doesn't contain any elements at all. It is represented by the symbol open, close braces or a null set symbol. For example, the set of dogs with 6 legs, the set of newborn babies that can walk. These are all null or empty sets because there is no dog with 6 legs or a newborn baby that can walk. Now, let's discuss the cardinality of a set. When we talk about cardinality of a set, that means we count the number of elements in a given set. It is denoted by a small letter n. The number of elements of the set can be determined either by manually counting or using an algorithm. For example, set A with the elements red, orange, yellow, blue, green, indigo, violet. We represent its cardinality as small letter n, open parenthesis, capital letter A, close parenthesis, equals 7. Or we can read that as the cardinality of set A is equal to 7. What about this another example? Set B with the elements 2, 4, 6, 8, 10. The cardinality of set B is equal to 5. You are right. We are now on our last topic for this episode, which is the operation of sets, namely union and intersection of two sets. First, let us know more about union of two sets. What do we mean by union of two sets? Think of two sets and name it as set A and set B respectively. Draw two circles representing these two sets. Set A contains the vowels of English alphabet, while set B contains the first 5 consonants in English alphabet. That means set A has elements of A, E, I, O, U, while set B has elements of B, C, D, F, G. If we combine the elements of set A and set B, what are its elements? Its elements will be A, B, C, D, E, F, G, O, U. You're right. That is an example of union of two sets. In other words, the union of sets A and B, denoted by A, U, B, read as A union B, is the set of all elements found in set A or in set B. It is the combination of all elements of set A and set B. Do you want more examples? Alright, for you to understand more, consider the following examples. Set A with the elements 1, 2, 3, and set B with the elements 4, 5, 6. Find A union B. You are right. A union B has elements of 1, 2, 3, 4, 5, 6. What about this example? Set B with the elements 2, 4, 6, 8. And set C with the elements 4, 8, 12. Find B union C. If you notice, there are common elements from both sets, which are 4 and 8. If we put its elements, we write it once. Then we can write it as B union C with the elements 2, 4, 6, 8, 12. Remember that if we talk about union of two sets, we just combine all elements of the two sets. If there are common elements, we could write it once only. We are already done with union of two sets. What about intersection of two sets? Consider this definition. The intersection of sets A and B, denoted by A inverted U B, read as A intersection B, is the set of all elements found in set A and in set B. In other words, it is the set of all common elements of set A and set B. That means, when we are finding the intersection of two sets, we are to find their common elements. Let's take examples that we did a while back. Set A with the elements 1, 2, 3, and set B with the elements 4, 5, 6. Find A intersection B. As you can see, the two sets don't have common elements. It is an empty set. Then we can write it as A intersection B is equal to open and close braces, or A intersection B is equal to null set symbol. What about this example? Set B with the elements 2, 4, 6, 8, and set C with the elements 4, 8, 12. Find B intersection C. If you notice, there are common elements from both sets which are 4 and 8. That means we write it as B intersection C has the elements 4, 8. Remember that if we talk about intersection of two sets, we just get their common elements. If there are no common elements, then it is a null set. I hope you learned something about our lesson on the introduction of sets, namely, well-defined sets, naming and representing a set, subsets, universal set, null set and cardinality of a set, and lastly, the operations of sets, namely, union of two sets and intersection of two sets. Again, I am Teacher Jeric saying, keep safe everyone, goodbye and have a nice day!